Dear students, welcome back. In the previous session we have discussed about metal rectifier. Now in this session we are going to discuss about the process called as rectification. So rectification means it is the conversion of alternating current into direct current. So this can be accomplished by either the metal rectifier or the diode wall. These are the two devices which helps in the rectification of alternating current, and these two devices used in the circuits for the rectification. Okay, and if you see this rectification, normally the thermionic valves are commonly used where the voltage is high, whereas the metal rectifier is used where the EMF is low as for direct current treatments. So these are the two devices, and these are the two conditions where these thermionic valve and metal rectifiers are used. Okay, so in the thermionic valves we have studied both diode and triode valves, isn't it? So out of these two, only diode valve is used as an rectifier, not the triode valve. Okay, now we will see the process of rectification. Okay, there are two types of rectification. One is half wave rectification and full wave rectification. So here you can see the graph of half wave rectification. So as we know that this alternating current which is having like this, the waves, it is having bipolar nature. Okay, here what happens in the case of rectification, so only one wave is taken and the reversed wave is not considered here, and this wave is obstructed, and again the next peak wave we are going to take in the rectification. So this is the thing happening in the half wave rectification. Now we will see what actually happens in the circuit. So this is a kind of circuit which is used in half wave rectification. This is the symbol of metal rectifier. Here it is used, and the symbol, the arrow of the head, indicates the direction of the flow. Okay, this is the symbol of a rectifier. Okay, if one wall, so either maybe one wall or metal rectifier is included in the circuit, current can pass in one direction only, and the flow is blocked during alternating half cycles. During alternate half cycles of the alternating current. So here this flow of current is blocked by using metal rectifier. As we know that these metal rectifiers or diode valves are used for the unidirectional flow of current. So alternating current will have bidirectional. So here what is happening? So during alternate half cycles of current, of alternating current is blocked. So how it happens now we will see. So here the continuous line represents the current flow, and here the dotted lines, which are the reverse waves, represent no flow of current. So what happened? The resulting current that is obtained is unidirectional. So only one directional current is obtained like this. Okay, unidirectional, and it is pulsating. Okay, so it is pulsating and also interrupted. Here the current is interrupted. here the flow of alternating, that is the reverse flow, is interrupting, and the process by which it is obtained is called. So such kind of waves we have seen, such kind of resulting current, that is unidirectional, pulsating and interrupted, are obtained by a process called as half wave rectification. Okay, if you see in this circuit, in this diagram, so this is the half wave rectification circuit. Normally I have already mentioned in the anode circuit. So here this is another type of circuit here which is used for half wave rectification. Here the circuit using the metal rectifier, so this is the metal rectifier, and AB is the secondary coil. Here this A and B is the secondary coil of the transformer which is supplying to the circuit. So this AB, this secondary coil, is connected to the circuit. Okay, that is output circuit, we can call it as output circuit, that is patient circuit we can also call it as. So what happens here? AB is the secondary coil of the transformer supplying the apparatus. Okay, and when current flows through the primary coil, this is the primary coil, an EMF is induced in A and B. Okay, and this EMF is applied to the output circuit. When A is negative and B is positive, then electrons pass from A through the rectifier and output circuit and back to the B. When B is negative and A is positive, no current will flow because it is unable to cross the rectifier. So this is the thing happening. So only if A is positive only, then electrons pass from A to circuit and then it comes back to B. If B is negative, so here what will happen? The electrons will pass through the circuit and it comes back to the rectifier and it is not completing the circuit, then there is no use of it. So here there is no flow of current taking place if B is negative. Okay, this is about half wave rectification. Okay, now we will see the full wave rectification in the next session. Thank you.